My name is Sharon Rayford. I'm with the Aquatic Invasive Species Program with the Green Bay Fish and Wildlife Conservation Office. In the 2024 field season, my team was able to survey 6 locations around Lake Michigan between the months of April and October. The surveys we were able to conduct were early detection and monitoring, Eurasian ruff, metabarcoding, grass carp, and environmental DNA. Starting with our early detection and monitoring, our invertebrate surveys were conducted at 6 locations around southern Lake Michigan. We set 20 to 25 colonization traps in the form of rock bags at each location for the duration of a month. We set 125 units and we recovered 85 units, which is pretty standard for this survey. Unfortunately, I am not able to share our results as we are still processing these samples in-house. Our fish effort, which is conducted by using traditional gear such as daytime electrofishing, gill nets, bottom trawls, and benthic-oriented gears, was conducted at 7 locations around Lake Michigan. The amount of effort and the distribution of effort varies between each high priority location based off of the bathymetry and total amount of time that my crew has available to survey each location. In total, we are able to conduct 522 units of effort. 2024 field season, my team handled roughly 17,000 fish. Of these, there were no new invasive species detected. We did add 2 native species to our historic collection for our locations. These included the black-side darter, which we handled in Green Bay, Wisconsin, and the Iowa darter in Grand Haven, Michigan. One of our high priority locations in Escanaba, Michigan, in Little Bay de Noc, we focused our efforts on sampling Eurasian ruff. The history of ruff within the Great Lakes begins with ruff showing up in the St. Louis estuary in Lake Superior in 1986. It is believed that these were introduced via ballast water and that they were then spread via interlake shipping. Within St. Louis estuary, ruff quickly became the most dominant fish in 1991. These fish then spread north and showed up in Lake Huron at Thunder Bay in 1995. There they moved to Little Bay de Noc in Lake Michigan in 2002. They were detected in the middle of Green Bay at Marinette, Wisconsin in 2007. There were a few records of ruff within the Marinette and Peshtigo areas. However, the population never became established. So therefore, one established population of ruff within Lake Michigan, and that is in Little Bay de Noc near Escanaba. We have an idea of how quickly these fish became established based off of the catch of ruff within gill nets from Michigan DNR efforts within Little Bay de Noc. In 2009, they started showing up within the bycatch of this survey at around less than 0.1 fish per gill net, but by 2022, they're showing up as about 6 fish per gill net. In 2024, my team paired with other fish and wildlife offices to try doing some trawling and gill net effort within Escanaba, and we completed 90 units of effort within the field season. In total, we removed 366 ruff from the population, and it was the 3rd most abundant fish after round goby and yellow perch in our overall catch. From each ruff, we collected length, weight, gender, otoliths, spines, and stomach, and we're working towards a publication to try and understand what is going on with this population in this. On to our metabarcoding survey. For those of you who are not familiar with this survey, this is a survey where we filter water in field, and the filter then gets processed by the lab to determine all of the species that are accounted for in environmental DNA. Our 2024 efforts focused on protocol development, such as determining spacing and location of using these filters. We hope to use it as a complementary tool to our standard early detection and monitoring, using it as another gear type alongside our gill netting and electrofishing gear types. Unfortunately, I do not have any data to present to you from our 2024 field season, as our lab processing is still ongoing, but I am going to share with you our field distribution in hopes that next year I can give you more data. We conducted our surveys in Burns Harbor, Indiana. This was our second year of doing a metabarcoding survey in this location. We chose this location because it's an area that we have yearly early detection monitoring data for the past 13 years. We, however, do not do our invasive carp eDNA sampling in this location. This past year, we allocated 240 filters to be split between 3 different seasons. So we had 80 filters per season, and we were looking at the difference of seasonality, spacing, and turbidity effects, as these all may impact the total species richness that we are able to determine with our processing. Particularly interested in turbidity effects, as suspended solids are likely to clog up our filter rapidly, and the less water that we are able to filter, the less environmental DNA we are likely to encounter. So therefore, we're trying to figure out what sort of limitation turbidity might have on our field sampling. Another location that we surveyed with metabarcoding was the Kalamazoo River. We were able to use 40 filters at half-kilometer spacing between samples on the system. This is an area that we have no early detection monitoring data of, so therefore we have not handled any fish on this area. But we do a yearly environmental DNA survey for invasive carps on this system, and we're very much looking forward to seeing how our metabarcoding data comes back to see what species might be occupying this system. We were also able to use 20 filters on the Milwaukee rivers within Milwaukee, Wisconsin. This is an area that we have yearly early detection monitoring data and yearly environmental DNA surveys on. Therefore, we have a very good idea of what the species composition is for this area. We also know that this area has had positive hits for invasive carp in the past for environmental DNA. So we're very interested to see how metabarcoding might pair up against these 2 surveys. And again, we don't have the results yet. Hopefully we can share that data next year. At the request of Illinois DNR, we were able to survey the Grand Calumet River, which spans across the Illinois-Indiana border, using 160 metabarcoding filters split between spring and fall sampling. This is an area that's very hard to sample with a boat, so we were able to conduct this survey using walk-in methods for metabarcoding. All of our filters were sequenced for carp using the qPCR markers, and then the samples were resequenced in the lab using our standard metabarcoding processes to see what other species might be within that river system. We also paired with the Nature Conservancy to do a partner project on the St. Joseph River in Michigan. We used 300 filters for this survey, focusing on collection technique, primarily trying to determine whether there's a difference in species assemblage detected with surface sampling versus benthic sampling, and lotic versus lentic, so therefore the main thalway or backwater areas, trying to see how well environmental DNA is mixed within the system, and if we need to be using our effort in a specific manner going forward, as these samples are relatively expensive to process between the initial purchasing all the way through to lab time and data in hand. The survey also had an upstream-downstream component, as there are very different habitats in those locations. Moving on to our grass carp survey, we have a dedicated grass carp team that surveys around Lake Michigan using specific survey parameters. This past year, our team was able to survey in St. Joseph River, Kalamazoo River, Grand River, Burns Harbor, and Milwaukee. Our gear that we use for this is boat electrofishing with high output grass carp specific settings. They run 30-minute transects, and this past year they were able to conduct 171 transects for a total of 4,600 electrofishing minutes. We also were able to set 5 hoop nets overnight in the St. Joseph River. In the 2024 calendar year, 5 grass carp were removed from the Lake Michigan Basin. 3 of these were from St. Joseph River, 2 of which were by Fish and Wildlife Service, 1 was by Michigan DNR, and 2 were removed from Burns Harbor, Indiana by the Fish and Wildlife team. The map in the middle of this slide shows all grass carp encounters in the NASS database. You can see that most of these focus on southern Lake Michigan. Therefore, our grass carp team also focuses its efforts on southern Lake Michigan, and you can see all of that effort in the right map as depicted by yellow circles. The red triangles are where grass carp have been encountered in the past. For the 2024 field season, the 3 fish were in St. Joseph River and 2 were in Burns Harbor, and you can see where those are in the map. In total, 29 grass carp have been removed by the grass carp strike team from Lake Michigan over the past 3 years. These range in size from 33 to 54 inches and 18 to 56 pounds. So these are quite large fish. These fish range in age from 7 to 25 years. And I know a lot of you are going to be very interested in this part, the ploidy. Of our 29 fish, 9 of these were diploid. This means that these fish were fertile. 20 of these fish were triploid, which means that they are not fertile. We're trying to figure out the origin of the diploid fish using otolith microchemistry. 2 of these have come back as aquaculture origin, and 1 came back with microchemistry that relates to Lake Erie water chemistry. So that's quite a distance to go from Lake Erie to Lake Michigan. Unfortunately, the rest of the diploid fish are still being processed in the lab. Moving on to our environmental DNA survey. This is a survey where we collect water that is then processed in lab only using qPCR markers for invasive carp as a complex and silver carp and big-headed carp. My team was able to survey 6 locations around Lake Michigan. These are the same locations that we sample pretty much every year. And this past year, we were able to conduct 3,520 samples throughout the field season. 4 positive detections amongst all of these. 1 positive detection was in the cause. Within our summer sample in June, we were able to conduct we collected 440 samples, 1 of which came back positive for invasive carp DNA. This was in Lake Calumet, which is approximately 8.5 kilometers upstream of Lake Michigan. We resampled this location in September, again using 440 samples, and we had no detections at that time. So the orange triangle depicts where the positive detection is, and our additional maps show that same orange triangle in relation to our other surveys. And I'll be reusing this framework moving forward. So you can see in the triangle in Lake Calumet in the lower left corner of that right map, and the black spots on the upper side of that map show where we had our early detection monitoring effort for this field season. And we had no eyes on or hands on any invasive carp during our field season, but I'm just trying to give you an idea of the density of our effort on the landscape. In Milwaukee, we had a sampling effort in May with 220 samples with no positive detection. Summertime, June, we sampled 220 locations and we had 1 invasive carp positive hit. This was 0.2 kilometers upstream of the confluence with Lake Michigan. Fall, we resampled at the request of the Wisconsin DNR. We did the same 220 samples and we had 1 silver carp positive 1 kilometer upstream of Lake Michigan. This area, it's in the past in the similar vicinity. Comparing these positive hits from 2024, again in the orange triangles, to our other effort, you can see how our grass carp team, our early detection monitoring effort, and our metabarcoding effort overlap. Moving on to the Kalamazoo River, we had 1 invasive carp positive in April. This was located in a shallow vegetated area, 6.3 kilometers upstream of the Lake Michigan confluence. We resampled in June and we had no detections, again using 220 samples. Again, comparing where that positive hit was compared to where we've put other effort in the 2024 field season, you can see where it relates to our metabarcoding effort and to our grass carp effort. And yet again, we're really looking forward to seeing our metabarcoding results to see if there's any invasive carp DNA that showed up in those results. Unfortunately, we won't be able to share that until we get that data in. Wraps it up for our 2024 field season. Of course, all of that effort would not have been possible without a very dedicated crew. This crew absolutely worked incredibly hard this past field season. To give you an idea of how much effort we were able to conduct, between the 140 work days between April 22nd and November 2nd, we completed 851 crew days. That means we had a crew of 6 to 7 out almost every single day of this field season. Looking forward to our 2025 field effort, our early detection and monitoring program will be completing fish surveys at 6 locations. Our invertebrate effort will be tabled for this field season as we do an internal review to try and standardize across all Great Lakes WICOs. Our metabarcoding effort will occur at between 4 and 8 locations. We are trying to do a soft rollout this year. This means integrating it with our early detection monitoring program as a new gear type, and also working on our communications with state and partner agencies, and hoping to improve our processing of field collection to results in a smooth manner. Our grass carp team hopes to possibly expand coverage throughout southern Lake Michigan, and also hopes to add gill nets to their survey, depending on conversations with partners and actual reality of the habitat they'll be in. And our environmental DNA team will be conducting the same amount of effort as they completed in the 2024 field season. If you have any questions, please contact me. My name is Sharon Rayford. You can email me at sharon_rayford@fws.gov. If you have any broader aquatic invasive species questions for Lake Michigan, please contact my supervisor, who is the lead of the aquatic invasive species team. Her name is Carrie Ann Hayer, so contact her at carrie-ann_hayer@fws.gov. Thank you for your time. Bye.